Hello, everyone, and very good afternoon. After a long time, we are meeting here, I guess. So, how is everyone? Before we start for the class, let me know if I'm audible or not, or if you can see the screen properly or not. Just let me know. Am I visible? Am I audible? Can you see the screen? Okay, that's great. So, everything is set. That's great. So, how are you? How is everything going on? Yes. कैसे हो सभी लोग? How is your preparation going on? I mean, for exams, JEE mains, NEET, or any other examination, I mean, board, whatever, for whatever things you're going to sit in coming months, how is your preparation? I mean, whatever is the status, first thing that you have to keep in your mind is you don't have to take extra tension on burden. Just you have to go with the flow. I mean, every day, every time, you have to just use your time properly, right? Whatever things you're doing, like if some exercise is getting finished and you're doing questions, you're following classes, you're following instructions, you're giving tests, and then you're analyzing your test paper. So these are small things that will add to your better or the best performance in the coming months. These are all small things that you need to do to get whatever you want out of at the end of this class 12, है ना? So that is important. So आज की क्लास में what we are going to do, we will be discussing questions, simple questions from electromagnetic induction. So question I have picked from NEET exam, JEE mains and CET. That is your state level examination of engineering, right? तो क्वेश्चंस यहाँ से मैंने पिक किया है एंड व्हेन यू विल लुक एट द पैटर्न ऑफ और द लेवल ऑफ क्वेश्चंस that are coming in NEET examination and JEE mains, there's so many questions that are directly coming from formula. I mean, simple formula based questions. And also in NEET and JEE mains, other questions that is not directly formula based. That is also one step solution kind of questions. I mean, you just need to know the concept and you need to know how to apply the concept to get the answer. So this is how you will be able to solve the question. So some questions like this I have selected for today class discussion. Okay, so let's start. This is the very first question on your screen. Very good evening, Janvi Nagao, if I'm pronouncing it correctly. I hope you all are good and great and doing well. I want all my students to be doing fine in terms of your energy level. You should not be feeling low or something just because examination is coming. You just have to perform. You just have to work every day. That's the thing. Okay? So don't take tension. Just get involved in your studies. That's the only thing. Still, it's not late. You can start from today also and get into some good college. Sure. Do this question. You can vote in the poll also, and also you can text me personally. So one answer I got, and let me tell you, you can retry because you have got the wrong answer. So maybe some calculation mistake you have done. So recheck for that, please. Yes, two answers I got. Why everyone is getting that answer? सही से देखो क्वेश्चन को, सही से डिजिट्स को पढ़ो. देखो, sometimes we know the concept but we fail to apply it properly. Maybe you are doing calculation mistake, or maybe you are solving it wrongly. Maybe you are not reading the questions properly. In place of 2 millihenry, maybe you are reading 1 milli or something. Such things happen. Okay? So check for that. So and now I feel like I should do the question. So let's end the poll and let's do the question. Question क्या है देखो. A current passing through a coil of self-inductance is given, that is 2 millihenry, changes at the rate of 20 milliampere per second. The EMF induced in the coil is what? So there is a single coil, right? There is a single coil, and let's say this is connected to a AC battery, you know, and current is passing like this. Let's say at certain point of time, this is plus, this is minus, so current will flow like this, and this current is changing at that instant at the rate of 20 milliampere per second. So we have studied in electromagnetic induction. In electromagnetic induction, we can write flux, flux through this coil. Flux through this coil को हम कैसे लिख सकते हैं? This will be equal to Li, है ना? Flux through this coil will be equal to what? Li, because of current flowing through this coil, है ना? There is no any other coil in the surrounding. So current flowing, because of current flowing in the coil, there will be flux because of this current through the same coil, right? अगर ऐसा coil है, current ऐसे जा रहा है, magnetic field will get generated in this direction. So there will be flux because of own current through this coil in this sense, right? So that flux is written as self-inductance L into idea is to revise whole thing through this question discussion. इसलिए मैं छोटी छोटी चीजों पे जा रही हूँ. तो flux is directly proportional to I हमने पढ़ा था, है ना? तो if flux through the coil because of current in the same coil हमें लिखना है, तो flux को हम Li लिखते हैं. L is self inductance, and if there are two coils, current is flowing in the one coil, and we have to calculate flux through the another coil. Let's say this is coil 1, this is coil 2. So flux through coil 2 will be directly proportional to current through coil 1. And phi 2 is equal to what? Mutual inductance between these two coils into I. ठीक है, यहाँ पे बात हो रही है सेल्फ इंडक्टेंस की, तो फाई इज इक्वल टू एल आई. ईएमएफ क्या होता है? ईएमएफ इज योर रेट ऑफ चेंज ऑफ फ्लक्स. तो माइनस d phi by dt minus has to do with direction of EMF getting induced. That is, it will come under Lenz's law. You all must have studied. So let's for time being ignore it. Minus d phi by dt. अब देखो phi को आप लिख डालो. Phi क्या है? L into I. L का वैल्यू क्या है हमारा? L है 2 into 10 to the power minus 3 into I. तो इसको कॉमन ले लो. 2 into 10 to the power minus 3 into di by dt, right? And di by dt is equal to what? 20 milliampere per second. So 20 into 10 to the power minus 3. So this is equal to how much? 40 into 10 to the power minus 6 volt. So this is equal to how much? 40 microvolt. So this is going to be your answer. So correct answer will be what? Correct answer will be your B. Okay? So this is your correct answer. Where you did the mistake? I really want to know. If anyone has any query, let me know. Because all of you answered or all of you went for option C. Whoever answered, they went for option C. So how you were getting option C? किसी को कोई doubt है? Any loss of clarity? If you feel like in this question, you can write in the chat box. Anyone having any doubt? Any doubt? नहीं है? अगर नहीं है तो let's move on to the next question. So correct option is your B. So let's do this question. ठीक है? Motional EMF से बहुत सारे questions आते हैं. So read this question carefully. Take 1 minute of your time and answer. ठीक है? I'm launching the poll. चलो, everyone do it. Okay, I got three answers, and all these three answers are different. Oh my God. ठीक है. Out of that, one is correct. ठीक है. Oh, okay, I got four answers. All four answers are different. That's great. चलो ठीक है, ठीक है. Let's discuss the solution now. ठीक है, I'm ending the poll. Discuss it. कहाँ पे गलती कर रहे हो तुम लोग? Let's try to understand. A long horizontal metallic rod with length along the east-west direction. So in this plane, this is east-west direction, and this is south-north direction. है ना? This is that direction, right? हमारा क्वेश्चन क्या कह रहा है? हमारा क्वेश्चन ये कह रहा है कि there is a rod and that is directed along which direction? It is directed along east-west direction. In this direction, there is a rod tip. So there is a rod tip like this. Okay. Now this is falling under gravity. So rod facing towards east and west is falling under gravity. So it will fall like this. If it is falling under gravity, it will fall like this. The potential difference between its two end will be. So इसके दो end के बीच का potential क्या होगा? Done है? So potential मूविंग रॉड के केस में पोटेंशियल कब जनरेट होता है? हमने एक टॉपिक पढ़ा था. हमने एक टॉपिक पढ़ा है मोशनल ईएमएफ. अब देखो मोशनल ईएमएफ कब जनरेट होता है? मोशनल ईएमएफ तब जनरेट होता है जब एक रॉड, कंडक्टिंग रॉड, जब मैग्नेटिक फील्ड में चल रहा हो. डन है? सो ऐसे भी हर केस में मोशनल ईएमएफ उसमें भी जनरेट नहीं होगा. या आई मीन व्हाट आई वांट टू से इज कि इवन इफ देयर इज अ रॉड एंड दैट इज traveling and that is kept in a magnetic field, both conditions are satisfied, then also there may be cases where EMF is not getting generated. I want to say cases where magnetic field is not equal to zero, velocity of rod is not equal to zero. In this case, there it is possible that EMF may not get induced. May not get induced. So we need to look carefully कि EMF induced कब होता है. जब मैंने पढ़ाया था तुम लोगों को क्लास में कि ईएमएफ इंड्यूस होने के लिए सबसे पहले तो ये जरूरी है कि जो वेलोसिटी है रॉड का, जो रॉड की वेलोसिटी है, दैट शुड बी परपेंडिकुलर टू द लेंथ ऑफ रॉड. ठीक है? लेंथ ऑफ रॉड से वेलोसिटी क्या होनी चाहिए? परपेंडिकुलर होनी चाहिए. पहली कंडीशन. डन. अब देखो पहला कंडीशन सेटिस्फाई हो रहा है कि नहीं हो रहा है हमारे केस में. सो हमारे केस में ये रॉड ऐसे है ना, ईस्ट वेस्ट डायरेक्शन में ऐसे है, और ये मूव कैसे कर रहा है, चल कैसे रहा है? डाउन. यानी कि रॉड इधर है और मूव डाउन कर रहा है. सो परपेंडिकुलर है. यानी कि हमारा फर्स्ट कंडीशन क्या हो रहा है? फर्स्ट कंडीशन हो रहा है सेटिस्फाई. इसको टिक कर दो. सेकेंड कंडीशन क्या है? दिस इज द फर्स्ट कंडीशन. सेकेंड कंडीशन इफ आई टॉक अबाउट, सो मैग्नेटिक फील्ड जो है वो क्या होना चाहिए? शुड बी परपेंडिकुलर टू द प्लेन ऑफ रॉड. जिस प्लेन में रॉड मूव कर रही है, मोशन ऑफ रॉड यहाँ पे लिख डालो. ठीक है? जिस प्लेन में तुम्हारा रॉड का मोशन हो रहा है उस प्लेन से मैग्नेटिक फील्ड क्या होना चाहिए? परपेंडिकुलर. नाउ नाउ क्वेश्चन इज कि यहाँ पे मैग्नेटिक फील्ड कहाँ है? दैट इज द क्वेश्चन. सो ईस्ट वेस्ट डायरेक्शन में एक रॉड है जो कि अर्थ के ग्रेविटी के इफेक्ट में नीचे की तरफ आ रहा है ना? सो यू ऑलरेडी नो वन थिंग, दैट इज देयर एग्जिस्ट मैग्नेटिक फील्ड बिकॉज ऑफ अर्थ, राइट? अर्थ behaves like a giant magnet, and that magnetic field direction is from south to north. That horizontal component of magnetic field, that is from where to where? South to north, right? So magnetic field is in this direction, south to north, somewhere in this sense. Done. Or mera that rod is falling in which plane? That is falling like this. तो plane of fall of rod क्या दिख रहा है? अगर मैं इस बुक से को प्लेन दिखाऊं तो प्लेन तुम्हारा कुछ ऐसा है. प्लेन तुम्हारा कुछ ऐसा है और मैग्नेटिक ऐसा है. समझ रहे हो? सो व्हाट यू कैन से हियर, सेकंड कंडीशन इज आल्सो गेटिंग सेटिस्फाइड. तो सेकंड कंडीशन अगर सेटिस्फाई हो रहा है तो ईएमएफ जनरेट होगा. यानी कि यहाँ पे ईएमएफ इज गेटिंग जनरेटेड. नाउ व्हाट इज द फॉर्मूला? So coming back to the formula will be dVL, where V is perpendicular to the L. That component of velocity I have taken over here. ठीक है? So this is this. Now let's check if velocity is remaining constant over time, because B is constant, length of rod is not changing. Is velocity changing? So yes, if something is falling under the effect of gravity, as the thing will come down, its velocity will increase. So V is increasing. V is increasing. So EMF induced will also increase. So what will be the correct answer? Correct answer will be your C. Okay. Anyone having any doubt in this? किसी को कोई doubt है? Anyone? किसी को कोई doubt है तो बताओ. If you are facing any difficulty, you can let me know. No? ठीक है. So correct answer will be what? Correct answer will be your C. Now let's move on to this question. Take 1 minute of your time and try doing this. ठीक है? I have lost the phone. Come on, everyone. Self-inductance of the solenoid is getting asked. So you just have to use the that basic formula of Faraday's law. Sorry. Okay, one answer I got. But you need to recheck your solution. Please recheck it. Maybe you're doing some mistake with the calculation. Because question is not at all tough. It's very basic and very easy. देखो, these are all a formula based question. Okay? Previous question was a bit conceptual. Again, that thing we have learned in our classes. Emotional. That is also there in NCERT. That concept is there, right? Okay, one correct answer I got. That's great. Those who have got it wrong, please try it. But confusion maybe they are thinking they're right. Okay, one more answer. Others, please, everyone, please do participate in answering. If you're not participating, it simply shows you're not you're not solving. Please do solve, everyone. What is the question? A long solenoid has 500 turns. So, yes, JNB Nagam. That's great. That's true. Okay? So there is a solenoid like this. I have a solenoid. Then when a current of 2 ampere is passed through it, how much value of current is flowing? Current flowing is 2 ampere. The resulting magnetic flux linked with each turn of the solenoid is this. Flux linked with each turn is how much? 4 into 10 to the power minus 3 Weber. Weber is what? SI unit of flux. The self-inductance of the solenoid. Just now I told you, flux through the coil, because of current in the same coil, is directly proportional to current. And here there is not single turn, there are so many turns. So flux here you will write as N into flux through the single coil, directly proportional to current. Okay? And this proportionality constant is equal to what? Self-inductance. Li, right? We have to put value. Number of turns, how many? 500. Plus single coil, how many? 4 into 10 to the power minus 3. L we don't know. Current is given, that is 2 amperes. So this is equal to how much? This is equal to 5 into 10, 10 into 100, 10 to the power 3 into 10 to the power minus 3. So L equal to 1 Henry. Henry is what? SI unit of inductance, be it self-inductance or mutual inductance. So Henry is SI unit of inductance. Remember. So correct answer will be what? Correct answer will be option A. Chalo, take your time and do this question. ठीक है? Okay, I'm relaunching the poll. You can answer over there. Also, you can text me in the chat box. So that individually I can tell you if you are getting it right or wrong, so that you can beat that. है ना? Come on, everyone, do it. This is also a basic question, okay? It's not difficult. Here, EMF induced is getting asked, है ना? Take your time, do it. Any of you got it? Okay, so far I got one answer, that is correct. Very good. Others, please, each one of you, please attempt it and then let me know your answer. Okay, one more answer I got, but you need to recheck. That's not correct, GNV Nagao. Actually, you have done some mistake in calculation. Some extra 10 you are getting. Extra 10, 1 into 0. Not 1 into 0, 1 0, sorry. Yeah, that's the correct answer. Yeah, that is great. चलो ट्राई करते हैं. A magnetic field of flux density. Flux density किसको कहते हैं? देखो, with terms we should be quite acquainted. This flux density means magnetic field. So it is talking about magnetic field. So that is Weber per meter square. And B का value कितना given है? That is 1 magnitude. It acts normal. It acts normal to an 80 turns coil of 0.01 meter square. So area of each turn is how much? 0.01 meter square. And the magnetic field is acting normal to the area. Then find the EMF induced in it. If the coil is removed from the field in 0.1 second, then EMF induced कब होता है? According to Faraday's law, when flux changes with time, EMF gets induced. That you already know, right? और flux का formula क्या होता है? B dot A. That is magnetic field or area vector का dot product is flux. So how you can change the flux? Change of flux means either magnetic field is changing, either value of area inside magnetic field is changing, or angle between magnetic field and area is changing. If these three, out of these three things, if any one of these is changing, you will get EMF, right? So यहाँ पे, if you do the calculation, if you look at here, coil is removed from the field in 0.1 second. So coil is getting removed from the field. What does it mean? It means that when coil is inside the magnetic field, there will be flux. So let's calculate initial flux when the coil is inside magnetic field. So then magnetic field का value is 1, area का value is 10 to the power minus 2. And what is this? Theta value is how much? So it is given. Again, there is number of terms also given. So flux को n into b dot a करना, ठीक है? Wherever number of terms is given, you have to multiply that flux formula by number of terms. क्योंकि एक टर्म के लिए b dot a है, n number of terms के लिए n into b dot a. So here 80 into, ये करना बहुत जरूरी है ना? अगर अगर ये कंफ्यूजिंग दिख रहा है, जो भी दिख रहा है, तो let's rewrite. So number of turns is 80, magnetic field is 1, area is 10 to the power minus 2. What is theta? So basically what is getting said here? मैग्नेटिक फील्ड इज नॉर्मल टू द कोइन। एरिया का डायरेक्शन हम कैसे निकालते हैं? तो एरिया का डायरेक्शन मींस नॉर्मल टू द एरिया। तो एरिया वेक्टर का डायरेक्शन इज नॉर्मल टू द एरिया, मैग्नेटिक फील्ड इज आल्सो नॉर्मल टू द एरिया। सो एंगल क्या है? थीटा हियर इज 0। सो cos theta is how much? 1. Yes. Jayenti Naga. Very good. Others can also respond in the chat box. Please do participate. So that will be this much. Now what is the answer that you are going to get? So your answer will be 8 volt. है ना? Okay, how much it is? No, not 8 volt. 18 into 10 to the power minus 2. So 18 into 10 to the power minus 2 will be how much? 0.8 volt. 0.8 volt. Right? Now we have to calculate EMF. EMF क्या होता है हमारा? Minus d phi by dt. I told you minus has to do with the sign. So magnitude अगर लिखना है तो simple d phi change in flux. Initial flux is this. Final flux is how much? If you write the final flux, so final flux में कितना लिखूंगी? 0, क्योंकि finally क्या हो रहा है? We are taking coil out of the magnetic field. So magnetic field finally is 0 inside the coil. So there is no flux. Changing flux will be what? Final minus initial. Magnitude wise अगर लिखोगे 0.8 volt. कितने टाइम में फ्लक्स चेंज हुआ है? In 0.1 second. Right here 0.1. So answer will be 8 volt. So what is going to be the answer? Answer is going to be 8. ठीक है? So correct answer is what? It is 8. Now let's do this question. Read the question carefully and do solve. 1 or 1.5 minutes of your time and do it. Everyone do try it. ठीक है? सभी को करना है. Okay, I got 2 answers. One is right, one is wrong. I don't know which is right, which is wrong. But some of you need to reconsider your option. This is studied directly from the formula. Most of the reality formula question. And this diagram is also given in your NCERT. So this is directly coming from NCERT. I have also discussed this thing in the class. Yes. Okay, only 2 answers. One more answer that is correct. Come on, everyone else. Everyone participate. क्यों क्या कर रहे हो तुम लोग? देखो क्लासरूम में बैठे हो ना, you giving the time to me. So that time should be yours, right? I like to only close if you're really participating. Otherwise, you're just letting your time go, right? Because you are made to sit in the classroom, you are sitting. Your time is really precious. You have to do a lot of work. I mean, there's so many examinations ahead. So you have to plan your things very much properly. If you're giving time here, then it should be here. That's my concern. Right now doesn't matter, yeah. So giving answer that is great. Okay, giving now. It doesn't feel like correct. Again, देखो मैं तुम्हें एक चीज फिर से बोलूंगी. You are doing literally that same वाला thing. You need to be careful with calculation, please. ये ना हमारे को also when I was a student like you. So calculating mistake is a very big mistake. You know, even if you know the formula, you know the concept, you know how to apply it, you will get negative mark because you are not getting the right answer just because of some silly mistake.
So that is what we have again done. रीचेक कर लो एक बार, उसके बाद बताओ क्या है. Okay. So I feel like now I can go with the solution. चलो ठीक है. Let's discuss it now. Many of you tried it. I feel like all of you must have tried it. Some of you are simply not voting in the poll. Maybe it's not possible for you. There may be so many reasons. So I should not make any judgment and pass that on to you. I know there are so many limitations. I understand you. So let's read the question. A rod of length 2 meters flies with a speed of 5 meters per second on a rectangular conducting frame as shown in the figure. है ना? So there exists a uniform magnetic field. D, the value is given. This is perpendicular to the plane of the figure. In the resistance of rod is this, current through the rod is. I mean, you don't need to check if EMF will get induced or not. Because already it is asking current, it means EMF is getting induced. ऐसे भी अगर check करो तो BVL का concept अगर check करो, your velocity is perpendicular to the length of rod, and also magnetic field is perpendicular to the plane of rod. So both conditions are getting fulfilled. EMF value is BVL. B value is 0.04. 4 into 10 to the power minus 2. Velocity is how much? 5. And length is how much? 2. 5 into 2 is 10. So this is going to be how much? 0.4 volt. है ना? So voltage is how much? 0.4 volt. Current will be what? अब देखो ये जो सर्कल है, ये जो मोशन है, ये सर्किट कैसे कंस्टिट्यूट करेगा? इफ यू इंटरेस्टेड इन नोइंग कि करंट किस डायरेक्शन में फ्लो करेगा, लेट मी टेल यू ये ईएमएफ इंड्यूस का बैटरी कैसा दिखेगा. दिस इज इंपॉर्टेंट. ठीक है. थोड़े से अच्छे क्वेश्चन आएंगे तो वहां पे तुम्हें डायरेक्ट आगे भी मैंने क्वेश्चन इंक्लूड किया है जिसमें डायरेक्शन बताना है. सो यहाँ पे ध्यान से देखो, मैंने तुम लोगों को बताया है कि व्हेन यू हैव टू कैलकुलेट द डायरेक्शन और द positive negative sign of motional EMF, for that what you do, you use the formula force वाला QV cross B. Force acting on a moving charge. क्योंकि conductor, we are talking about motion of conductor in magnetic field. Conductor has free charges inside it. So based on free charges are moving towards which end of the rod, we can tell which will be positive, which will be negative. So positive charge पे देखो force यहाँ पे किधर लगेगा. Velocity किधर है rod का? In this direction. So let's say this is x direction, so this will negative x, this is y direction. Done है. So velocity is towards minus I cap. Magnetic field किधर है? Into the plane, that is minus k cap. और डायरेक्शन निकालना तुम सबको आता होगा. कैसे निकालते हैं हम वेक्टर का डायरेक्शन? I j k. I cross j is k cross I is j, and here I cross k. I cross k is what? Minus j. So here force का direction is towards minus j for the positive charge. So positive free charge inside the rod will come towards A, है ना? क्योंकि minus J means this direction. तो इस डायरेक्शन में पॉजिटिव फ्री चार्ज आएगा, तो इस बी की तरफ क्या बचेगा? नेगेटिव चार्ज. है ना? सो अगर तुम्हें यहाँ पे बैटरी बनाना है रॉड के साथ जो कि मोशनल ईएमएफ आ रहा है, तो क्या होगा? यहाँ नेगेटिव होगा, इधर पॉजिटिव. बी की साइड पॉजिटिव और ए की साइड नेगेटिव. तो करंट कैसे फ्लो करेगा? ऐसे. So this is how current will flow. Current का वैल्यू निकाल लो तो इजी है. That is 0.4 volt divided by 3. So this will be equal to 4 by 3 into 10 to the power minus 1. So this is equal to how much? 1.33 into 10 to the power minus 1 ampere. So this is equal to 133 milliamp. ठीक है. This is not 1.33 ampere. This is 1.33 into 10 to the power minus 1 ampere. That is 133 milliampere. क्योंकि इसको हम क्या लिख सकते हैं? 133 into 10 to the power minus 3 ampere. So this can be written as 133 milliampere. So correct answer will be what? It will be. I hope I have answered your queries. Anyone has any doubt? किसी के पास कोई डाउट है? If you have, you can let me know. डन है? चलो ठीक है, कोई डाउट नहीं है तो ओके. नाउ लेट्स डू दिस क्वेश्चन. दिस केम इन नीट. This is a very simple question. I hope you all will be able to answer. So I am relaunching the poll. Harish, very good. That's great. Others also, everyone let me know the answer. Yes, Chainvi Nagam, that's correct. Yes, two answers I got. Chainvi Nagam. It's not that answer. Sorry. Recheck. Recheck karo yaar. Okay, six of you answered and five of you are correct. That's great. Yes, student. What's your name? जेनवी नागांव. कैसे आ रहा है तुम्हारा? देखो देखो, तुम शायद भूल रहे हो एक बेसिक सी चीज. आई फील लाइक मे बी यू आर फॉरगेटिंग. सो नेट मैग्नेटिक फ्लक्स थ्रू एनी क्लोज सरफेस, तुम लोगों ने पढ़ा होगा इन इलेक्ट्रोस्टैटिक्स, दैट इज गॉस लॉ. पढ़ा है ना? दिस इज गॉस लॉ. टेल्स व्हाट इट टेल्स? दैट flux, electric flux through closed surface, that is E dot ds, is equal to Q enclosed by epsilon naught. Same thing if we use for magnetism. So magnetic flux through closed loop will be equal to what? So see here, for electric flux, we are writing electric flux through closed loop is equal to charge, total charge in, inside divided by epsilon naught. So this is electric charge. Here we can talk about magnetic charge. And I have told you magnetic charge means if there is a magnet, it has north pole and south pole. North pole को we call positive magnetic charge, we give it pole strength plus m, and south pole को we give pole strength minus m. है ना? This thing we have discussed. So if you are taking a closed loop means 3D loop, and if you are keeping any magnet inside it, it will have both plus m and minus m, because you cannot cut a magnet into such a small portion which will have not both south and north pole. No matter how short you are making the magnet, it will always have two poles, right? So if magnet is inside a closed loop, total magnetic charge will always be zero. So magnetic flux is going to be zero. Okay, so Gauss law, if you translate this to magnetism, you will get magnetic flux through closed surface equal to what? Zero. Okay, and whatever flux we were calculating, B dot A, we were doing this for 2D surface, not for 3D surface, if you remember. Yes, Jane B Naga. है ना? So B dot A जो भी अभी तक हमने निकाला, we calculated that for 2D surface. If we talk about 3D surface, then magnetic flux will be what? Zero. ठीक है? चलो. Now do this question. This is interesting. अगर तुम लोगों ने सोलेनॉइड का थोड़ा सा डेरिवेशन किया है म्यूचुअल इंडक्टेंस का, then you will be able to solve it very easily. But you should try. ठीक है? So let's try. 1.5 minute I am giving to you. Try it and let me know your answers. ठीक है? I am relaunching the poll for you. Okay, I got one answer. Uh,
यू नीड टू रीचेक, एक बार रीचेक करो, टेक योर टाइम एंड रीचेक इट, ठीक है। ध्यान से देखो एक बार, फ्लक्स कैसे निकालते हैं, म्यूचुअल इंडक्टेंस कैसे निकालते हैं, देन दैट इज गिवन इन योर एनसीईआरटी। एनसीईआरटी में तुम लोगों ने एक चीज किया होगा कि देयर वर टू कॉइल्स, राइट? ओके, या दैट इज करेक्ट नाउ। So we have done one thing now. There are two coils, एक bigger coil we took, है ना? And then there was another smaller coil embedded inside like this. And we calculated M12 and M21. That is mutual inductance of coil 1 with respect to 2. And M21 means mutual inductance of 2 with respect to 1. We have done this derivation. And when we did it, we got these two equal. ये दोनों ही हमें क्या मिला था? Equal मिला। So that equal thing indicated towards what? It indicated towards whenever you are asked to calculate mutual inductance, go with calculating M12 और M21 depending on your convenience. क्योंकि अगर M2 कोई भी म्यूचुअल इंडक्टेंस पूछ रहा है, दोनों ही तरह से निकालो, इक्वल होगा. So always go with that one choice which is more easier to calculate. जैसे यहाँ पे जो मैं कह रही हूँ वो समझ में तब आएगा when I will explain it. Two conducting circular lobes of radius R1 and R2 are placed in same plane with the centers coinciding, right? If R1 is far far greater than R2, so R1 कुछ ऐसा coil ले, ठीक है? This is too big, and the smaller one is what? It is too small, so this is like this, ठीक है? This radius is how much? This radius is R2, and this radius is how much? This is R2, ठीक है? एक काम करो, इसको coil 1 ले लो और इसको coil 2 मान, bigger one को I have taken 1 and smaller one को I have taken 2. So if I go on to calculate mutual inductance of coil 1 because of 2, coil 1 because of 2. So N12 I am going to calculate. How I can do the calculation? So calculation के लिए मैंने बताया, चलो एक काम करते हैं, इसके थ्रू करंट I1 मान लो और इसके थ्रू करंट को क्या मान लो? I2 मान लो. What I am going to calculate? Mutual inductance of coil 1 because of 2. So we will try to see what is the flux getting linked in coil 1 because of current flowing in the coil 2. So flux through the coil 1 because of coil 2 will be directly proportional to current flowing in the coil 2. है ना? Phi1 is directly proportional to what? I2, and Phi1 will be equal to what? M1 to I2. Correct? Phi1 will be therefore magnetic flux through the coil 1 I am calculating because of current flowing in the coil 2. Okay, so this is like this. Now what will be the flux to coil 1? Because हमें निकालना है M12, है ना? तो Phi1 हमें लिखना पड़ेगा. So flux through the coil 1 क्या होगा because of 2? सेकेंड में तुम्हारा करंट कितना फ्लो कर रहा है, सेकेंड में करंट कितना जा रहा है? I2 जा रहा है ना? और because of current flowing in coil 2, what is the magnetic field getting generated? So magnetic field at its center will be how much? This is a circular coil. So magnetic field at the center of second coil कितना है बताओ? That is equal to mu naught I2 by 2 pi. क्या होता है फॉर्मूला? दिस इज राइट 2 pi r. तो mu naught I by 2 r, नॉट पाई, पाई नहीं होता है, सॉरी. तो 2r2 लिखोगे, है ना? लेट्स राइट इट नाउ, 2r2. सो दिस इज मैग्नेटिक फील्ड. अब देखो इसका मैग्नेटिक फील्ड इसके अंदर ही होगा, है ना? बाहर की तरफ मैग्नेटिक फील्ड विल बी व्हाट? प्लीज रिपीट B2. अच्छा ठीक है. यहाँ पे देखो व्हाट आई एम कैलकुलेटिंग इज, जैसे मैंने यहाँ तक तुम लोगों को समझ में आया, मैंने Phi1 लिखा. Phi1 इज व्हाट? फ्लक्स थ्रू द कॉइल 1 बिकॉज ऑफ कॉइल 2. तो हमें ये देखना होगा कॉइल 2 जो है कितना मैग्नेटिक फील्ड जनरेट कर रहा है, तभी हम 1 के थ्रू फ्लक्स निकालेंगे बिकॉज ऑफ कॉइल 2. सो कॉइल 2 हमारा काफी छोटा कॉइल है ना? इसका मैग्नेटिक फील्ड इनसाइड में क्या होगा? इनसाइड के सेंटर पे कितना होगा? सो सेंटर पे B2 में लिख रही हूँ. A magnetic field because of coil 2 at its center, that is mu naught current flowing through it divided by 2 R2. This is the formula, mu naught I by 2R. Current flowing because of magnetic field because of current flowing through a circular coil, and that magnetic field we are calculating at its center. So this is the formula basically. So ये फॉर्मूला मैंने यूज किया. अब वो यहाँ पे मुश्किल क्या है? मुश्किल ये है कि अगर तुम फ्लक्स निकाल रहे हो, अगर फ्लक्स निकाल रहे हो तो देखो मुझे कॉइल 1 के थ्रू फ्लक्स निकालना है. 1 का एरिया कितना बड़ा है? 1 का एरिया कितना बड़ा है? 1 का एरिया कितना बड़ा है? अब मुझे ये बताओ कि ये जो कॉइल है, जो सेंटर में कॉइल रखा हुआ है, उसकी वजह से मैग्नेटिक फील्ड सेंटर पे तो हमें पता है दैट इज D2. बट व्हाट विल बी मैग्नेटिक फील्ड एट दिस पॉइंट, दिस पॉइंट, दिस पॉइंट, दिस पॉइंट? सो देयर सो मेनी पॉइंट्स, राइट? इट्स वेरी डिफिकल्ट टू कैलकुलेट. वी डोंट नो द फॉर्मूला. देन सो वी नो फॉर्मूला फॉर एक्सियल पॉइंट्स, बट ये एक्सियल पॉइंट के लिए एक्स डिफरेंट होगा, इसके लिए डिफरेंट होगा, इसके लिए डिफरेंट होगा. देयर इनफिनिट पॉइंट्स और हर पॉइंट पे मैग्नेटिक फील्ड क्या है? डिफरेंट डिफरेंट. So we cannot calculate flux through the coil 1 because of current flowing in the 2. हम नहीं निकाल सकते क्योंकि दिस B डॉट A जो करोगे यहाँ पे, here B is what? Here B is getting variable. ये B क्या हो गया है? Variable हो गया. हर पॉइंट पे डिफरेंट डिफरेंट होगा. That is very difficult to calculate. So we cannot calculate M1 too easily. So what we can do? Let's see if we can calculate M21 because M1 to M21 both are same. Done. So let's check with that. अब देखो यहाँ पे अब मैं क्या कैलकुलेट करना चाह रही हूँ? M21. So M21 का मतलब म्यूचुअल इंडक्टेंस ऑफ कॉइल 2 बिकॉज ऑफ with respect to 1. So current flowing in 1 को मैंने I1 लिया था, इसको मैंने I2 लिया था. So flux through coil 2 will be directly proportional to current flowing in coil 1, right? And this phi 2 को किसके बराबर लिखोगे? Mutual inductance of 2 with respect to 1 into I1. Now let's calculate phi 2. Can we easily calculate phi 2? Phi 2 is what? Phi 2 is flux through the coil 2 because of current in coil 1. So coil 1 को अगर आप ध्यान से देखो तो coil 1 का सेंटर भी यही है, और coil 1 में जो करंट फ्लो कर रहा है, बिकॉज ऑफ दैट मैग्नेटिक फील्ड एट द सेंटर कितना होगा बताओ? ये हो जाएगा म्यू नॉट I1 बाई 2R1 एट द सेंटर, है ना? बट हियर इट विल बी डिफरेंट, हियर इट विल बी डिफरेंट, हियर डिफरेंट, हियर डिफरेंट, हियर डिफरेंट. बट in our question it is given R2 is far less than R1. So we can approximate one thing, what magnetic field is at the center, same magnetic field is at every inside point. हम अप्रोक्सीमेट कर सकते हैं क्योंकि ये सर्कल काफी छोटा है. सो इसके सेंटर और इसके सर्कमफ्रेंस के बीच का डिस्टेंस इज वेरी स्मॉल. सो वी कैन अप्रोक्सीमेट. Phi 2 we can write like this is B1 into area of coil 2, that is pi R2 का square. If that is R2, then R2 ही है ना? Yes. Pi R2 का square is equal to M21 I1. अब B1 का वैल्यू आप पुट कर दो. B1 is how much? Mu naught I1 by 2R. So this will become how much? Mu naught I1 by 2R1 into pi R2 square, and this is equal to M21 I1. I1 कैंसिल हो जाएगा और देखो M21 का वैल्यू क्या आ रहा है? M21 का वैल्यू है म्यू नॉट पाई R2 स्क्वायर बाय R1 2R. ठीक है? So it is directly proportional to R2 square by R1. R2 square by R1. So correct option is A. मैंने बताया ना M1 to M21 इक्वल होता है. दिस इज वेरी सिग्निफिकेंट. दिस इज हेल्पफुल इन कैलकुलेटिंग म्यूचुअल इंडक्टेंस. ये क्वेश्चन बहुत सारे एग्जामिनेशन में आया है. लॉन्ग बैक इट केम इन एम्स, then it came in NEET 2024. It may came in your state exams also because this has got repeated so many times. And so it's a very common question. So you should be clear about. I hope you are clear. Clear है सभी लोग? Harish, Janvi, Nagaon, and everyone else out there. Clear है सबको? Start it.
जेबी नामा के रिपीट आप क्या कहना चाह रहे हो? आई नीड टू रिपीट इट. Can you make it clear, please? What I said कि जहाँ पे तुम्हारा approximation कर सकते हो, always go with calculating. Okay, you have got it. That's great. Thank you. चलो, जे मेंस का क्वेश्चन है. क्वेश्चन इज वेरी इजी. ये जस्ट कॉन्सेप्चुअल क्वेश्चन है ना. फैराडेज लॉ का तीन स्टेटमेंट जो पढ़े हो या दो स्टेटमेंट जैसे भी पढ़े हो, only that will be useful in solving this question. Go ahead and let me know what you get. ठीक है. Cross the poll, you can answer over there. Okay, I got one correct answer. That is great. Okay. Yes, Harish. Correct. Can we now come? You need to again consider. In one option, you're getting confused actually. Means there are two options correct now. A, C, C, D, 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 B, and C. So one out of that is correct. Another one is wrong. Rohit, yes, that's great. That is correct. Okay, so let's go through the question. The induced EMF can be produced in the coil. I have already told you कि EMF कैसे induce होता है. EMF induce होता है जब flux change होता है. And how can flux change? So flux can change either because you are changing the magnetic, or you are changing the area value, or you are changing angle between magnetic field and area. So let's go through all the options. Moving the coil with uniform speed inside uniform magnet. So if there is a uniform magnetic field and you are moving the coil inside it, so flux is not changing. It's a still B into A in this case, right? Moving the coil with non-uniform speed. If it's moving non-uniformly, flux through it is constant. To the non, it is inside the magnetic field. No flux getting induced. Now, option C आप देखो, rotating the coil inside the uniform magnetic field. If you are rotating the coil, मैंने ये question करवाया भी है. If there is a coil and it is rotating, then what will happen? There are cases कि जहाँ पे तुम्हारा EMF induce नहीं होगा, but दोस्तों cases में EMF will get induced. Can लिखा है यहाँ पे, must नहीं लिखा है ना. So if you are rotating it such that angle between B and A is getting changed, EMF will get induced. So option C can be correct. Changing the area of coil inside the uniform magnetic, certainly true. So D, C and D. So C and D is where B. That, so that is your correct answer. Just you need to look at these things carefully. चलो अब ये जल्दी से आंसर इसका बताओ. This question is too easy. You just need to put the formula, get the answer type question. देखो इतने इजी क्वेश्चंस भी आते हैं. I am time and again telling you कि जेईई मेंस में 6 से 7 क्वेश्चन डायरेक्टली फॉर्मूला से होगा. नीट में 13 से 14 क्वेश्चन डायरेक्टली फॉर्मूला से होगा. So you have to keep these things in your mind. Formula knowing basic is very much basic and again very much important. It's all the pillar, you know, upon which you will build concepts and all complex approaches. No approach in complex, the basics are clear. I mean, that is where the thing lies, you know. Flux is given, right? Induced current through the coil at t equal to 2 seconds. Induced current निकालना है. Resistance is given. So go with it, everyone. Therefore, we don't have much time, so I cannot give you much time now. So let's go with it. क्वेश्चन में कुछ नहीं करना है. फ्लक्स क्या है तुम्हारा? 5pq plus 4t square plus 2t minus 5. ठीक है. ईएमएफ क्या होता है? ईएमएफ होता है माइनस d5/dt. सो फ्लक्स का मैग्नीट्यूड क्या होगा? 15t square plus 8t plus 2. ठीक है. सो दिस इज दिस थिंग ईएमएफ. करंट क्या होगा? करंट होता है ईएमएफ बाय आर. सो करंट कितने टाइम पे निकालना है? 2 सेकेंड पे. सो 15 इंटू 2 का स्क्वायर 4 प्लस 8 इंटू 2 प्लस 2 डिवाइडेड बाई आर करोगे. आर कितना है? 5. When you will do it, you will get the answer. I just wanted you to do one question. This is the last one. So इसको करके बताओ मुझे एक बार. This has to do with Lenge's law. So I wanted you to do this. So do it, please. Everyone, let me know the answer of this question. Previous question बहुत easy था. Formula use करना. So that is why it's advanced. Harish, I couldn't understand you. What you're telling? One minimum previous question. What is it? Acha, 1 minute previous question. Okay, 1 minute. It is this. Sorry. Okay, thank you. इस क्वेश्चन का आंसर बताओ जल्दी से सभी को. Okay, I got 2 answers. All those 2 are incorrect. And that is real pain. And GMB Nagao. You need to reconsider. Coil is placed in magnetic field B as shown in the figure. Current is induced in the coil because B is what? GMB Nagao again not. सो करंट इंड्यूस का वैल्यू दिया हुआ है. करंट इंड्यूस का डायरेक्शन दिया हुआ है. डायरेक्शन ऐसा है. सो तुम्हें लेंजेस लॉ क्या कहता है? लेंजेस लॉ टेल्स दैट इंड्यूस्ड करंट विल अपोज द इफेक्ट बिकॉज ऑफ व्हिच इट वाज induced. Then so basically induced current opposes the original thing present already there. So induced current is in which direction? It is in anti-clockwise direction, and because of that magnetic field will be in which direction? Outward. So because of induced current, magnetic field is getting induced in outward direction. इसका मतलब ये है कि जो फ्लक्स रहा होगा पहले, like EMF get induced because of what? Change in flux, है ना? And then because of EMF get induced because flux is changing, right? So this change in flux created magnetic field in outward direction. इसका मतलब क्या हुआ? इसका मतलब ये हुआ कि आउटवर्ड फ्लक्स मस्ट बी डिक्रीजिंग विथ टाइम. जैसे देखो आउटवर्ड फ्लक्स फ्लक्स क्या हुआ? डिक्रीज कर रहा होगा टाइम के साथ. इसलिए इंड्यूस करंट क्या कर रहा है? इंड्यूस करंट इज इंक्रीजिंग आउटवर्ड फ्लक्स. आई टोल्ड यू कि लेंजेस लॉ क्या करता है? अपोज करता है. सो रीजन क्या था फ्लक्स को जनरेट होने का? सॉरी, ईएमएफ इंड्यूस होने का रीजन क्या था? आउटवर्ड फ्लक्स वाज डिक्रीजिंग. तो इंड्यूस करंट जो होगा वो क्या होगा? उसको अपोज करेगा, डिक्रीज को अपोज करेगा. यानी कि इंड्यूस करंट आउटवर्ड फ्लक्स को इंक्रीज करेगा. तो अगर क्वेश्चन उल्टा दिया हुआ है कि इंड्यूस करंट इज इंक्रीजिंग आउटवर्ड फ्लक्स, इट मींस दिस करंट वाज गेटिंग इंड्यूस्ड बिकॉज़ आउटवर्ड फ्लक्स वाज डिक्रीजिंग ओरिजिनली. So these two statements. ठीक है. तो correct option will be what? It will be A. You can reconsider. I need to end the class because 11th class is in waiting. So thank you so much everyone for staying here and answering all way through. Thank you so much, and I wish you all the very best for all coming days. Okay, we will meet again definitely. Till then, bye bye everyone, and take care of you. Lots of love to everyone. Bye. Take care. Thank you. Thank you so much.